も経ったしさ、仕方ないか。春を運ぶ風はまだ冷たくて、僕の上着を着た君が少し咲いた桜を嬉しそうに見上げていた。あの後別の恋もしたよ。でも急に君の顔が浮かぶことがたまにあって困ったよ。あれやめてよね。それでも連絡はしなかったよ。酔った勢いでの電話は置いといて、季節を上書きするたび思いは下書きした。終電迫る改札の前、あのさを言い出せたくて、人並みに消える背中に願った時間よ止まってくれ。愛じゃなくて恋じゃなくて、最後に残るのは好きなんだ。今さら何を言ってるんだろう。気づけなくて傷つけて絵に描いたような後悔です。駅前の喧騒がやけに耳につく、そんな夜だ。今年もまたあの花が咲いた渋谷駅古墳のあの公園で、なんとなくあの日と同じ上着でいた。冬の終わりを告げる風が吹いて、冷たくなった方を腕にうずめて悲しくなったんだ。君の匂いがした。これでよかったのかもな。黒い髪を染めた君がこの街のどこか今日も笑うのなら、なんて僕も変わったかな。愛じゃなくて恋じゃなくて、最後に残るのは好きなんだ。今さら何を言ってるんだろう。気づけなくて傷つけて絵に描いたような後悔です。駅前の喧騒も君となら世界に二人きりだったんだ。
Assalamualaikum and very good morning. So today we are going to learn timing diagram. Before we start, as usual, please submit your attendance through Spectrum. Okay, let me share again. Wait. Also cannot see. Network problem ni. Oh ada. Okay. Alright. Okay. Let's start. So today we are going to learn timing diagram. Timing diagram is one of the diagrams in interaction diagram. So far for under interactions, we have learned sequence, activity, and state. So, and also interaction overview. So this one is the last one as a timing diagram. So before we start, let's recap what we have learned so far. Okay. So in our first week, we have learned, not first week, I think second week and third week, we have learned use case diagram and the use case description. This is the most critical part in software development because this is the only place where people can understand what are the functionalities of the software that you are going to develop. Alright, so basically one use case diagram for one system or one subsystem, and then we can also group all or related use cases as one package, right? Module by module. Okay, and then after that you have learned class diagram. So the class diagram is basically the structure of the system. What are the objects or classes involved for the software development? So we also has to include the operations from the user's perspective. Basically, we got it from the use case description, and then the relationship between them. Okay, we can also group that. Sometimes the class diagram you develop is based on the whole system. Okay, but sometimes you cannot have one. You cannot draw a class diagram for one whole system because the system is too huge or maybe it's too complex. So what you will do is you break it into subsystems. Okay, that is why in your use case diagram, it's quite good for you to module them first so that your class diagram will be based on the modules you have produced in the use case diagram. And then after that, you learn sequence diagram. Okay, this is the first interaction diagram you learn. So basically, we know that the rules is one use case equivalent to one sequence diagram at this point, all right? And then each sequence diagram has lifeline, okay? Object of class and operation that needs to be consistent with the class diagram. So whatever you mention, operations involved in the class diagram, it must be appear in the sequence diagram as well, okay? Then from the sequence diagram, you also learn activity diagram in week 8. So it's more or less like sequence diagram, but during activity diagram, you really can have make use or utilize swim lane where you can module up some operations, some action, some activity based on roles, for example, or based on hardwares. Okay, so the rule is still the same. One activity diagram for one use case. Okay, and then after that, you have learned interaction overview diagram in week 9. Okay, so here basically you want to focus on complex sequence diagram. Alright, so there will be some sequence diagrams that are very complex. There are so many interactions involved. So you can simplify using interaction overview diagram. Okay, so it means that it doesn't apply the rule of one use case equivalent to one IOD. No. Okay, that one use case only for one sequence diagram or one activity diagram, but for interaction overview diagram, you must figure out which sequence diagram that are complex, right? So that you will simplify it into interaction overview diagram. Sometimes we use IOD to represent the conceptual interaction for the whole system. Okay, because you're going to use a lot of reference frame. Okay, so another one is network teruk hari ni. Hujan. You have learned state diagram. So in the state diagram, okay, state diagram for one class. I receive a lot of questions from students over the weekend about state diagram. You have to remember during our lecture, I'm not sure whether those who ask me is the one who involved with the activity, active learning or not. But then you have to remember, but in the active learning, you have to come up with the state diagram based on class. Sometimes you come up with, you start straight away draw a state diagram, and then I will ask you, what is this state diagram for? Which class? So state diagram is purely based on some classes. It is expected you have more than 20 classes. Okay, if you have less than 20, there's something wrong with your design, especially for your project because your project all are very huge. But then from the classes, you have to figure out which class that has dynamic behavior that can have state change from, you know, undergraduate to graduate student, from unregistered to registered user, this kind of status. So you have to look into this. If the classes or objects has this kind of behavior, changings of behavior, then those classes must have state diagram. How many? Actually, there is no formula for that because I do not know how you interpret your project. Okay, it could be you can have like 10. The least, most of the time I said 3, but actually you should have more. It is impossible that you have very little because your project is more or less the same. So you have to really think about your classes, the dynamic behavior of your classes so that you can have state. If you cannot interpret, it means that there's something wrong with your use case description. That is why I told you earlier, your use case description should have long explanation. And then you ask me what is the least number. You say that, then I say 3. And then some group put 3. Then you got stuck with all this diagram. You must explain in detail, then if you have detailed explanation, then you know where is the dynamic behavior that can be parked into your state diagram. Okay, let me share again my notes. What is it? And then, okay, I think I got problem with this. Don't waste my time. Open to my yeah. Well, I can hear my voice. said just now. Okay, share. Okay. So after state, then we have today, alright, timing diagram. So timing diagram focusing on time, definitely, and then is for one lifeline, or basically I always refer it as one plus. Okay, let me show you. Okay, now we are here, right? So basically, we are going to learn the purpose and notation of time diagram and how to develop the timing diagram lah. Okay. So timing diagram is used to show the length of time that an object or its lifeline stays in each state. Okay. Before this, we have learned about state. Now we want to look at how long it takes to change from one state to another. So this is the example. Timing diagram is used to show the length of time that an object stays in each state. So time increases from horizontally left to right. Okay, so the notation is you will have a frame, and then it's always start with SB. Okay, and then followed by the name of the lifeline. All right, you can remove this bracket. There's no such thing as this bracket, and then you have the name of the object here, and then all states involved, okay, for this particular object, state 1, 2, and 3, right, and then is the duration lah. Below here, you have time unit, okay. Time unit is depends, sometimes you talk about seconds, sometimes you talk about months, year, okay, it depends lah, I do not know about this, alright, and then okay, so from state 1 to state 2, the change is based on message 1. So you will mention it here usually, so that we know that what message triggers the change of state. Okay, so here you will put the message 1 here, and then here to here. Alright, so the duration constraint. So the duration constraint, we put it in the curly bracket. Okay. And then after that, or maybe you can have time constraint. There are three kind of constraint actually. Okay, first is a text constraint. Text constraint is the one, this one, the message. All right, what constraint or condition that we make the change. All right, and then another one we put it as a duration. Duration, it means how long it takes. Okay. And another one is a time constraint from A to A plus what. Okay. So regardless what constraint that you're going to use, what notation that you're going to use, it doesn't matter. As long as we understand that it reflects whatever you have mentioned in the sequence diagram or use case description. Okay. All right. So lifeline represent an individual participant in the interaction. It is possible to model several lifelines in the same timing diagram. Okay, it doesn't matter if this lifeline involve in a similar operation. Jangan kacau saya boleh. It is possible, okay. Messages sent from one object to another can be depicted using simple arrow. And the start and the end point of each arrow indicate when each message was sent and when it was received. Okay, so this is the example. Before this, you have looked into the notation of frame name, and then you have to include the object name or class name. This one class name lah, and then the state name, and then this is how you draw. There are two ways in drawing timing diagram. I'm not remember the name. So far the notes that Dr. Hazrina prepared is using this notation. There is another one using, my life, you cannot see me. Okay, just use this one, but sometimes if you go to Google and then you found another notation, that is another way to draw timing diagram. Okay, so don't say like this one is wrong ke, that one is right ke, that one is wrong. There are two kind of notation. So we use this one. And then okay, before this we have looked into these lines. Right, now we want to see this message. This message shows that when state 1 of object 2 change to state 2, so there is a message that we trigger, okay, the change of state 1 to state 2. So at the same time, once this change happen, so object 1 will change its state from state 1 to state 2. So it means that this part, okay, this part and this part happen because of message 1. Alright, and then but then the time is different. This one, let's say T2, and then this one happen at T3. So it means that first this thing happened, okay, and then second at T3, this state 1 of object 1 will change, okay. There is, okay, if you see another one is this, the slanting part, okay. This slanting line represent duration. Duration, it takes from here to here, okay. It means, let's say 2, 3, this one 4, sorry, this one 4, this one 5, this one 6. So let's say T5 to T6, it means 1 second. So state 2 will change to state 3 within 1 second. This one, if you have nothing, there is no slanting, like this one, right? No slanting, right? So the changes is abrupt, is one after another. There is no time involved. Okay? So this one, it will take some time. It will take time to change. So it will be like slanting. Okay, and then usually we will mention the duration involved for this. Okay, so this is another syntax or notation that you have to know for timing diagram. Right. So the major notation of UML timing diagram is a object or class, state, state lifeline, event, duration constraint, time unit, and timing ruler. Okay. So this is another one, simpler version. Same thing actually. Okay. So this is another example. So this is what I told you about the duration. Okay. This is the time constraint. Alright, this one you have to change this because it should not be like this. It should be SD and something. Alright. Okay, so if you look at this one, lifeline of the user basically is a object or class name, and then these all are states, either to wait cut, to wait access, and then code cut out are the message involved that change the state. Alright, and then this is how you put the duration constraint and time constraint. The time unit, usually we just put 0, 1, 2, 3, 4, 5, 7, 8. So we know that how long it takes from 2 to 3 based on D until 3 times D. Okay, So the time unit is can be millisecond, hour, is up to the system requirement. Okay, and it's quite varied. Alright, it doesn't mean that you must have like same size. Usually when you learn about X and Y, from 1, 2, 3, 4, it must have same size, right? But it's not necessarily. Okay. Okay, and event triggers the change of state, and state can also be changed when the activation ended. Okay, are the four type of trigger events is call event and signal event. So call event corresponding to the arrival of the procedural call to an operation, and signal corresponding to the arrival of a signal, non-procedural or an ad hoc calls. Okay, this one it must be consistent with the operation in class diagram and sequence diagram. However, usually we don't really put the parenthesis here. Okay, so this is what I told you just now. The change from unlock to lock is based on message lock. Okay. Alright. So for this one, an event triggers the change of state. Other four types of trigger event is time event, whether you want to use time constraint or duration constraint. Okay, so if we refer back to state machine grade rate, okay, this is the state, okay, and then all the condition used from pending to active, active to lapse is based on time. Okay, so when this happen, so it means that you will have timing diagram. Okay, so again, this state machine is based on class. See, class grade rate. It's not based on use case or sequence diagram, activity diagram. No. Okay, it's based on class. Right. And then, okay, from here, then you can see it start from pending. Okay, so it's start from pending lah. This is the pending. So what condition or constraint that make it change to active? So rate start less or equal to current date. So you put it here. Okay, and then it change lah, change to active. So from active, and then it change to lapse with the condition rate finish date less or equal to current date. So if you look at, and then after that, change to lapse, alright. So for lapse, since you have this another condition, after 1 year, then this state machine of class grade rate will finish, okay, will be final. So it means you have to show the duration of this 1 year. You see? When you have this situation, then you have first you need this notation to show that okay, after 1 year, there is a duration for lapse state. Okay, 1 year. Then once is after 1 year, after 12 months, then it's finished. It means that the grade rate will be, we can say maybe it's off, from the system. So you will have this line go down and X. Alright. If your state diagram does not have this, from lapse straight away to the final pseudo state, so you will not have duration, right? So you will not have this line go down and X. You get me? Okay, so you have to be careful on this, because we know that for state machine, there are some situation where you have condition or guide, or maybe we say trigger for the last state to the final state. But then there are situations that you don't put anything. It's just like, that's it. Okay, so you don't have this line and X. That's for timing diagram. Example 1. Example lah. Grade rate. Alright, so this is another one. We always use this one, okay, because things happen at the same time. Alright, so event trigger the change of state. Other 4 types of trigger event. Change event. A change event occurs whenever a specified condition is met. Okay, change event. This is the event. Yeah. So example, the specified condition is met. Okay, the one that I told you, the guard, the condition, whatever that trigger the change of state. So in this case, we have SD exit car park. This timing diagram is meant for exit car park. Exit car park is a sequence diagram. Usually it's a sequence diagram lah. I assume it's sequence because it start from verb. Okay, but then in this sequence diagram of exit car park, there are 2 classes have states: parking barrier and ticket machine. Okay, so for example, this ticket machine first is inactive, right, until a customer insert ticket. Once you insert ticket, then the ticket machine is active. Alright, so that's why it changed from inactive to active because of the insert ticket. Okay, so once it's active, then it will trigger the parking barrier. Right, so the parking barrier, by default, is a lowered state. So at T1, the customer insert ticket, then the ticket machine active. At T2, it will make the parking barrier change its state from lowered to raised. Okay. However, to raise the barrier is not like one shot. Okay, it will take some time. You know, there is a time for that. So that's why it's a little bit slanting here. See? So I do not know how long it takes, maybe 1 second, 2 seconds, I'm not sure. But then it's not straight away up, okay? So we take some time to raise, and then after that it's maintain, raise. Right, until the car left the area. So once the car left the area with this condition, then the parking barrier will lower down within some duration. It's not simply lowered down. Alright, so then after that is maintained as in the lower state lah. During this time, the ticket machine is active. Okay, during the parking barrier lowered and up, raised up and then lowered down. So during this time is ticket machine is active lah. But then how the ticket machine change from active to inactive, we do not know. This one is end until exit car park. Alright, so that one is another story. Any question? Okay.
Doctor, I have a question.
Okay.
Should the classes we use in the timing diagram be the same as the state machine diagram?
Yes. It must be the same. It cannot be different. If for your project, if it's not as this, you just realize, oh, we should have this, then you have to modify your class diagram. And then
so
actually,
it's just like state machine diagram but with time durations, right?
yes, with the time duration.
Okay, thank you, Doctor.
Doctor, I have a question.
Yeah.
So, for example, like in state machine diagram, there were conditional states also, right? Like, if this condition is fulfilled, this thing will happen. If this condition will fulfill, the other thing is will happen. So, does it also happen in the timing diagram also? Like, um, if this condition is happening, the like for example, if the pin is correct, it will validate, but if the pin is incorrect, it will ask you to write the pin again. So, do we have to put both of these things in the timing diagram?
Yes, it's just like this. Okay, I know that some of you already have state diagrams, all right? And then you realize that your state diagram do not have time. Okay, so what you have to do, and then when you refine back, when you think through, you realize, oh, we can add time for this some situation. So what you have to do is you have to go back to your all states diagrams and then figure out which state that has time. Are all states must have time? No, not necessarily. There are some states do not have time. Okay, so for example, unregistered student to registered student. There is no time for that, isn't it? It just it depends on that student when they want to register themselves. Okay, so but there are some situation where you want to put, okay, for unregistered student must register to system within 3 days. So you have to put time. So it depends on your project. So once you have decided which part that of the state diagram that you want to put time constraint, then you can draw timing diagram. And then it means that whoever did a state diagram must modify his states to include time duration or time constraint. Because you can put many constraints in one transaction, right? In one arrow, you can put so many things right now. So then just add in lah. Okay. Any more question? Okay. All right. So let's proceed with this one. Okay, this one. Okay, we have a case study here. Seriously Secure is a company specializing in the production of security systems. A terminal fixed next to the door is changed from idle state to validating state. See, it's already mentioned. So we have this state and we have this state. When a user enters his PIN, after validating, the terminal will capture the face image of the user and will send the image to face recognizer, which is located in the server. This will change the state of the face recognizer. This one is another state for another object. From idle, okay, I change the color blue, to recognizing state. So the blue one is for face recognizer, and then the red one is for door. Terminal fixed next to door is changed. Okay, door lah basically. Upon successful facial recognition, the face recognizer will notify the door to unlock. So there is another one, right? Unlock, and it is meant for door. So it means there is a lock situation and unlock, right? Okay. So we have three color here: red, blue, and purple. So you have three objects. To be competitive in the market, Seriously Secure also specify the following non-functional requirements. Okay, so the non-functional requirement says that terminal shall capture the face image is not more than 0.5 second. Okay, and the door shall take not more than 1.5 second to unlock after a user's face image has been successfully captured by the terminal. So draw a timing diagram for the control door class. Okay, control door class. Oh no, this one is for, doesn't matter, sequence diagram. Sequence control, controlling, no. What? Open the door. Can we change password? Let me check. Okay, control door. Yeah, this one is taken from sequence diagram. This one taken. Why I cannot use my iPad. Taken from sequence diagram. Okay. And then we have 3 classes: door terminal, face recognizer, and door. Okay. First thing to do, you must to know what are the classes involved. So based on here, okay, let me change this one. Okay, and hopefully my network is okay again. Okay. Okay, first step. Okay, first find classes or objects involved. Okay, so for this case, you have this door, right? And then you have face recognizer, terminal fixed door. This one is actually the terminal fixed next to the door, right? It's a terminal fixed to the door, face recognizer, and this one is the door. Alright, so you got 3 classes. Okay, and then second, find the states. Okay, so you know that terminal will have either, okay, and then validating, right? So far lah, and then this one is for this. And then we got face recognizer from idle to recognizing state. Okay. And then you got door for unlock. Alright. So this is the states that you can get from the case study. Alright. So next is you can straight away draw the timing diagram, right? Because the one for those who for those that is very straightforward lah. Okay, so you know that this one okay is timing diagram frame label. Timing diagram frame label. Alright, this one taken from sequence diagram. Okay, so you know that you have door terminal, face recognizer and door. Okay, and then okay, so for door terminal it has idle and validating, right? And then it has another one, capturing image. Capturing image is quite tricky, because at this time it says we'll capture the image and we send image to face recognizer. This one is quite tricky because the word is a verb. It doesn't state that, oh, this is a state, capture image state. No, this one you have to figure out, right? Why this part is a state? Because it has relation to the face recognizer, where the face recognizer will change the state from idle to recognizing. Okay, so this part is you really have to think through. You will got stuck when you want to change from the face recognizer from the idle state to recognizing, because you need capture face image. So this is actually happen. Idle and then you will enter pin. See? Okay, I enter pin and then it will change to validate. Usually student will do like this. You will put idle first, doesn't matter, and then validating, and then you will draw like this, and then you will draw validating, and then you will have capturing image. Here is another one. So then you know that it will change from idle to validate, then you draw this line. Tak change lah, sorry you all. My never slow today. Okay, alright, let me repeat. Usually once you have figured out what are the classes involved, what you have to do next is to list down all the states. Alright, so now I have idle, I have validating, and then I have another one, capturing image. Alright, and then I will draw this. Okay, this line, because this one image is on that state. Okay, this line means is in that state. Okay, then after that, I know from the case study it will change from idle to validating, and then it will change from validating to capture. Alright, but then on the last sentence there is a there is one sentence. It says that the change from idle to validating because or due to enter pin. Then I put here enter pin. And then there is a non-functional requirement stated that the validation process, validating, it takes that less than 0.5 second. So then I put here less than 0.5 second. Then it will change once it's finished 0.5 second, then it will change to capturing image. How long it takes to capture image, it doesn't mention. But it says that once it's capture the image, it will send image. Right? It will send image. So during this, after they have sent the image to the terminal, basically store it in the database, whatever, and then what happens is the face recognizer will activate. How it activates is from idle to recognizing. So this happens. Okay. So then send image, then face recognizer will activate by recognizing the face. So it will change from the state idle to recognizing. Alright. So how long it takes is less than 1.5 seconds to recognize a face. Okay. Once they recognize the face, then they will unlock the door. So the unlock the door is the event trigger. So that's why you have this. At the same time, it will trigger the door. It means that it will change from lock to unlock. Okay. So then after that, you have to annotate lah where the time constraint is for this part. Okay. And then once finish this, then you just put this timeline. Okay. This one for T1, this happened. T2, the change from validating to capture image. So at T3, okay, send image and then idle to recognizing, and at the same time door is still locked. Okay, and another change is during T4 to unlock the door. Okay, where the duration is 1.5 seconds. So this is timing diagram for sequence use case control door. Any question?
Doctor, one thing I wanted to ask. So for example, if we have a document like in the previous one where the time is always already given, and we think we identify a state and which we think that there would be a time involved there. Like for example, the capturing image, like if there was no time given, normally we would have drawn it a bit slanted because it takes a bit like 1 second to capture the image. So if the time is already given, so should we just go with the whatever the given in the document, and the states which don't have the time we just draw it like straight line, or we can like make it slanted as well if we.
Okay, thank you. No, very good question. You have to make it slanting because it's just like this. There are some of your projects involve like network connectivity. It takes time, right? Just like we are handling it now. We're having it now. It takes time. So it's always slanting. Let's say it means that, for example, for this scenario, if I want to use this scenario, this case study, it takes to capture image. This one, let's say, you can put here from T to T plus 5 seconds. I can put like this. So the capturing image must be between T until T plus 5 seconds. Alright? Or I can put another way, something like the previous one. Less than 5 seconds. That one is during capturing image. This one, it means that if I have this, it means that during capturing image. The one that is slanting is this. If, okay, let's say door. Okay, let's say I want to use door. Okay. Okay, let's say for the door to go to unlock, it will take some time, right? So you will have something like this. Go like this. So it means you will have T5. So the duration here is 0.5 second for the door to change lock to unlock. That one, the slanting is the change. But then let's say for the unlock, okay, this one, what does it mean? During changing of state. Okay. The first one, this one, during that state. It's not like changing during in the state. The state, how long it takes. For example, I like the door one. I use the door example. To change from lock to unlock, it will take 0.5 seconds to change. So you need to make it slanting. Okay, and then the door will be unlocked within 1 minute only, for example. Alright, so you will have this from here to here. I use another notation, 16 seconds, for example. Okay, so then in that case, you will have this T6. Okay, so then there will be two different situations. During the unlock state of the door is only within 60 seconds. So you don't need to, you just the line, one line, straight line. Okay. But then to change the state, if there is a duration, then you have to make it slanting. If there is no duration involved, then you just straight away, straight without slanting. Instant. You don't, it's not only instant. You don't care. I cannot say instant. You don't care how long it takes. For example, student, okay? Once you become a new student, you have to register through the system, UM system, right? How long it take for you to register to the system? We don't care. Let's say the system do not care. Alright, so you can have straight line, the vertical line, because you don't care the time. If you care about the time, the student must register within 3 days, then it will be slanting. If you care about time, because you know that when you talk about state, there is always time actually. There is always time. It's a matter whether that time is compulsory or the requirements of your system. Anything in this world will change. Anything. And it will involve time. Change means time. However, we talk about software development, system development. Whether your software takes that time consideration seriously or you do not really care. You know, is it part of the requirements or is not part of the requirements? Okay. For all the steps, do we need to specify a time or can skip some? Up to you. It's your project. Logically. That's why the case study, the company names is seriously secure. So we consider about the, face recognition with the time and etc. Must be secure. Right? And any other question?
Doctor,
Why I always receive this question? Can we use actor as a class? Actor is always a class. Actor is always a class. Okay, I hope the rest who did not attend this lecture session will listen or watch this video, because I noticed that I keep on answering the same answer. It's always class, it's always object. You have user. Let's say your actor is student. The object is Ali bin Ahmad. So it is an object. Or the best thing about state diagram, if you base on actor. Actor change, right? From registered to unregistered or maybe you can have like public to registered user. The one that you got stuck with the use case diagram, do you remember? But then doctor, this one is before. Actually, you're talking about change of state of your main actor. You have to recall back your software project description, your use case description. Actually, this one will involve change of use case description a lot. I will give you another example. Any more questions?
Doctor, the part selanting part, is it memang untuk compulsory punya time
If you have duration to change the state. Let's say the one that I give example, all new students must register to the system within 3 days. So you become registered student, right? So it's compulsory within 3 days. Then it's slanting. But then if your system says that the student, you don't really care. All new student has to register using this system to become registered student for system. You don't really care how long it takes. 1 year, 3 days, 3 weeks, you don't really care. So then it's not slanting. It will straight line.
The vertical one, we don't need to write like the same as slanting one.
That instant. It means it changed. It just changed. It's not instant tau. I cannot say instant. It just changed. When you say instant, there is a time for that. Instant mean time. No. It just change. Okay. How to draw the states in timing diagram which is controlled by a certain condition. State successful or failure will be decided first. Okay, the default state is what? It's not success and failure, right? Something. And then it will change to state. And then it will change to failure. Timing, okay. It's about lifeline tau. It's just like this. If I can relate success and failure based on student, right? So the student will be have one state, idle, new student. Means no result lah. So let's say, and then CGPA more than 3, change to success. Okay, and then success lah, for one semester, 14 weeks, right? And then what CGPA less than 3, then it will change to what we call that, failure. That's it. But then doctor, isn't it that what if the student maintain the CGPA? There is no such thing of if else in timing. We just want to show what happened in between the state, from new student, which is no result, to successful, to failure, or from failure to successful. That's the method. The what you call it, the if else situation only can be seen in the state diagram, not in timing. It's just like the door lah, right? Because face recognizing, and then suddenly unlock. What if they cannot recognize the face, or the face is a criminal face? They will lock the door, right? You see? We don't consider if else situation. All is a good scenario lah. Good scenario. You can have but in the company, in the industry, they will have another timing diagram for both situation. Let's say for control door, for what do you call that, best scenario, and then another one is a worst scenario. But then if you have best and mixture of best and bad scenario, that one we don't consider that. That one you have to go back to the state diagram or sequence diagram that where you can show all this. Yes, so it runs smoothly. Yes, main flow. We don't consider exception. I'm going to show you next question with the use case description. Loop, no loop. Even worse, loop, no. Any more questions? I think your batch is really memang betul lah, you all memang pandai-pandai lah. You all come here with the highest CGPA kan? Because last time your senior don't bother, never. I think adalah one to ask me. The rest, we have no question, doctor. Betul lah, you all memang pandai-pandai. Because I love state and timing. I love class, state, timing. This one is related. So when I teach this one, usually students don't bother. Kau frustrated jugalah kan, macam tak minat topik ni. Okay, this exercise, I give you 10 minutes, alright? to read this, because this one I think is very close to your project. Okay, you can go to the, I already upload this PowerPoint to the Teams. If you open the PowerPoint slide, you can click the attachment. The attachment will link to the PDF file. Okay, this one because PowerPoint slide, so it's not really clear lah. This one, I got this idea from Zahrin Group. Okay, I think you are the only one project for political kind of system, right? So, so I choose his project to get some idea. Yes, ho. Use case that has exception, we just draw the smooth flow is enough. Yes. Okay. So this is for voting, e-voting system. Okay. I just realized, Zahrin, your use case, not use case. Your sequence diagram are horrible. So please redo before you submit the last report. Okay, I will give you all the marks for the last report. It means that you still have time to change your sequence diagram, activity, class, whatever, everything. Okay. All right. So this one I took for the vote for a candidate. Okay, and then with the description. All right. This is the description lah. Okay, about a voter. So from here, okay, you can see that it has precondition, it has post-condition, okay, and it has main flow. However, I do not consider the exception alternate flow because I don't want to waste my time to draw a complete sequence diagram for Zahrin Group. It's not fair, isn't it? So it should have exception flow as well, right? But then I, remove that. So these are the main flows. Okay, from the main flows, because they're proposing using blockchain to ensure the security of the voting process. Okay, it's very interesting lah. Okay, from here, main flow, I come up with a sequence diagram. Okay, using blockchain Ethereum. I'm not using Bitcoin. Okay, all right. So here the sequence diagram for vote for a candidate. We have voter, okay, and then voting page. Normal lah, you go for voting page, right, to vote. And then once you vote a candidate, then the process of the blockchain happen. Okay, first it will go to Ethereum virtual machine, and then it will access to Ethereum network. And then after the process finish, and then we'll pump the information to the database. So the database is basically, I call it as a proposal table. Okay, this one is the entity lah, or the vote counted in this record proposal table. Okay, so here you can see how I change the sequence diagram, the one that you have now, which I include together with the states. So that is why I told you, whoever doing state diagram, you have to talk with the sequence diagram person, because the sequence diagram must change accordingly. So you can see that I choose voter. Voter, in order for the voter to vote, he must register first. So this is his condition, his state registered. Once he start view personal info through the voting page, okay, maybe he wants to look at whether the information is correct or not, matrix number, name, address, okay, and then he can start voting. All right, so now he's in the state of voting. He can choose a candidate, enter a ballot token, and then once the voter only choose a candidate and enter a ballot token. So next is more on the system side. You see, so the token will be sent to the Ethereum virtual machine, and then the virtual machine is idle at the beginning, of course, and then once you receive the ballot token, and then also the IP address, and then it will start generating kecap 256 key. Okay. This one is a blockchain. They're not using common, typical encryption key. That one is a very, we call it as a pathetic one. This is a canggih one, okay? So, and then so once they create, this one I put time. You can see how the process of creating to close. See, I got time here. This is how you put the time in the sequence diagram. Sorry, PIC of sequence diagram, you have so many things to do. I try my best to give you full mark if you do it well. Okay, so you start from A until A plus 30 seconds. I put everything here. Okay, and then during that duration, during 30 seconds, the network will generate the key and then do the mining, the block mining. Okay, once it happened, and then I put there. So it's slanting. See, the process of mining to access the network, Ethereum network, it took 10 seconds because we assume that network is always has problem, has delay, right? So I put 10 seconds, and then it will give back smart contract to the virtual machine. So once they receive the smart contract, then this process between mining and the creating smart contract within 15 seconds only, because it must be fast. Okay, and then after that, it will send the block header to the network for the network, Ethereum network, to create Ether block. I'm not sure how many network students here, but then for software engineering students, you must know this as well. If not, you cannot develop system. Okay, and then that one within 30 seconds. So they will create Ether block lah. The currency, the e-wallet thing. I don't put it here. Zarin, they put e-wallet, blah, but I don't. You will make things confused. I'll just put Ether, okay? And once the Ether is created, then the vote counted, and then save it into the table, the proposal table. So once you can see. Okay, I want to show you this. This happened at the same time. Once they create the block, it means Ethereum virtual machine can close. You can close the virtual machine. It means it can stop running lah. It happened at the same time. Okay. Then pass the vote count to the database, proposal table, and then store block information, because in the Ether block, they got so many things. It's not only many things lah, so blah, 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 blah. I don't really remember. Okay. If you're interested, you can read more. Then once you store into the proposal table, then it will display successful. Okay, thank you very much for your vote, whatever lah, to the voting page. Alright, so it means that the user know that by now his vote has counted, and then his ballot token is already removed from his e-wallet. And this process from here to here, 5 minutes. You know lah, voting cannot be so fast, right? The one that you will be in the system, they will give you 5 minutes. But inside there, the process in the network, blah blah, it should be very fast to ensure security. Is very, you know. Okay, so this is the sequence diagram based on this main flow. So I already mentioned everything here. The registered voter, see, you have to change. Tally with this. Enable to view personal information through a voting page. This one is the plus. Then you change the voting voter Can start voting by choosing, ING here, a candidate of his choice, and by entering the ballot token. He has 5 minutes to complete the voting process. The voting process, 5 minutes. So I put it from that one, T now here, to 5 minutes. Okay. Then the one, okay lah, tak ada apa-apa. Once the machine receive ballot, the status change from idle to creating. So you can refer the description with the sequence diagram. The question is, draw a timing diagram for voter and Ethereum virtual machine. Okay. So you can draw now and then share your answer. This one will take some time, so I think I give you 10 minutes this one. So until 10:25. Another 5 minutes. In the meantime, you can ask me questions. I'm not sure Zahrin is here or not, but you can use my answer for your project, but then you have to modify a little bit to include exception open flow. And then,
I'm here, Doctor.
you can use this one, but I change your use case. You use cast vote, right?
Yes,
For
Doctor.
me, so I change to vote for a candidate, but doesn't matter lah. I know that you are referring to the cast vote and my vote for a candidate, same thing. You can use my use case description, but then you have to include the exception flow. What if, all the, right? And then you change it.
Yes.
Then you have to change your sequence diagram. I already give answer for you. If you
Thank you so
want
much,
to,
Doctor.
kalau tak nak, tak apa.
Nampak lagi promising lah. But it's okay lah. Can.
Promising, dia kata. This is the answer, not promising.
I mean, kind of detail lah. So, can lah. I can refer to it also lah. Yeah. Thank you, Doctor.
Are you a network student?
Not really. I'm an AI student actually.
Oh, AI.
Yeah.
Anyone network in the group?
Anyone network in the group?
Tak ada.
I don't think so. No one. Not.
Oh, I should include AI kat sini. Never mind lah, tak apa.
Yeah.
Oh yeah, I'm muted. I give you. I'm waiting for your answer. Thank you. Anyone wants to share answer? Okay. Okay, dah siap belum? Anyone wants to share? You can see from here. Here is the sequence diagram. So if you have done your state diagram, so sequence diagram must change. You have to include the state inside the sequence diagram. Okay, and then you have to change the main flow again. the main flow of the use case description. And then once the timing diagram is done, then you realize you need to change the sequence diagram as well to include the time. Okay. Ada siapa-siapa nak share jawapan? Senang je. So we have voter, we have EVM. So, lukis macam mana? So voter we have registered, voting, voted. So voting, voted. Right. And then Ethereum, we got either creating, close. Okay. So next, registered to voting. Okay. And then to voted. Okay, never mind. So registered to voting is based on view. It should be straight lah. And this one happened when they personal control. So then the voting started. So this one is for the upper. Okay. And then after that, the Ethereum is idle until it receives IP address and ballot token. So this one is What? Receive. Ballot token. Never mind. And then creating to close. This one is the 14, 13, 14. Okay. Creating to close. Close when it's send block header. So yeah. I think I need to see. Right. Okay. So all of this is still voting. Right. And if we change to voted once, display unsuccessful vote received. Wait. Voted. Display successful. Okay. I cannot do that one. Tak berani. Try. Okay. Okay. So this. Okay, when the voter has to be registered, right? And then once he view, and then it will change to voting, and then during the voting, he can choose a candidate, enter ballot token, kind of thing, and then send ballot token, and then send IP address. So at that time, is the virtual machine is idle. Okay. And then it changed to creating once is the voting page send ballot token. So this one I put receive lah. Okay, the ballot token and IP address. So at that time, the voter is at the voting state. Okay. And then during the creating state, what happened is it will generate kejap 256 key, and then mining for 10 seconds, and then create smart contract, okay, and then send back, okay, send block header. So this one is within 30 seconds. Send block header and then it will change to close. Alright. So at that time, okay, send block header or iter block, create iter block. This one is better. Let me put the time here. This one is between A to A plus 30 seconds. Okay. Voting is between T to T plus 5 minutes. Okay. And then okay, if you look at the question, right, you can see that there is a mining where include 10 seconds, within 10 seconds, and then create smart contract within 15 seconds. However, there is no such thing as state involved, change of state. You see, there is no change of state during the mining to create smart contract. All of this happens during creating state of virtual machine. So what you can do actually, you can have this, you can omit that because it doesn't involve state, or you can include it together by putting it somewhere here.
Doctor,
Hmm?
based on the sequence diagram that you gave us, the vote for candidate, so the states also has to be added in the sequence diagram, or is this only for the question?
You must include in the sequence diagram.
Okay, noted, doctor. Thank you.
Okay, so there is mining. This is with smart contract. Sorry, I don't underestimate. Okay, let me. This one, you can have send block header and then change to close. Okay, send block header and also they got two. One is this one, send block header, another one is iter block. Right, so last one is you put timeline T0. Oh, usually start from T1. T1, T2, you got T3 here, you got T4 here, you got T5 here, and then you got here 6. Okay, and then that's it lah. Okay. So display message, okay. Oh, I forgot. Another one after T6, then it will go to. I missed another one. It's close. Okay. And then display message. Then you can have this. Then. how long it takes for the system to display message. Because it doesn't mention, then nothing. If not, then you can put it. So it's something like this. Right, timing diagram for vote for a candidate, lifeline, voter, and Ethereum virtual machine. Okay, question? Oh, it's very sensitive. Okay, does it matter what order of objects in the diagram? Like, oh, it doesn't matter. Even the order of the states also, it doesn't matter. You can put registered first on top, and then voting, and the last one voted. Okay, mine I put registered at the bottom, and then voting, and the top is voted. That one is not, it doesn't matter. And then we don't have to put arrow connecting voter to Ethereum. Wait. Oh, you can put arrow, but then that arrow is to represent what message? Hmm. Oh, that is C. Oh, yeah lah, good question. Thank you, Islan. No wonder lah I use receive. Because it should be sent. Receive, okay, right. But then you better use arrow here. Sorry. Sorry. Then I put like this. Okay, this one it's not at T1 tau. It's not at T1 because T1 is they send they key in the candidate, they choose a candidate, right, and then key in the ballot token, and then after that happen, then the next process is send ballot token to the virtual machine. So it's not like it can be like this. Send mana tulis sini lah. Okay, I take the last one instead of ballot token. Send IP address. Take the last one. So it will change to creating. Yes. Sometimes that's why sometimes they put something like this instead of. Tapi duration I forgot the notation. What is it? You like this. A plus 30 seconds. Is it like this? Never mind, I use it. Because if you can use, wait, I forgot. Duration. How do I put like that? Okay. Okay, then in that case, I change this because it's confusing. It's not confusing lah, but then clearer. Right. That's the problem with handwriting. This to here. Right. A plus 30 second. And then I think same thing goes to B. And I just put like this so that I can put in the bracket B, dot B plus 15 second. Okay. Right. Any other question? Okay. For the time is T1, T2, oh yeah. Better put T1, T2. T represent time. It's better you put that way. Yes. Okay.
Doctor,
Yeah.
when I see at the voter part where doctor write T dot T plus 5 minutes, isn't it that 5 minutes included in the TT or not?
T is 0 lah.
T is 0.
Or T is like pukul berapa? What time is it now? 1 o'clock. So plus 5 minutes, 1:05.
Oh, but then the whole duration is still 5 minutes, right?
Oh, you want to put 5 minutes on it? Yes, you can. You can also have this notation. You just put 5 minutes. Yes, you can.
Yeah. Because from what I understand, the voting process takes 5 minutes only. So basically, the whole thing is only 5 minutes, right? So we need to write TT. Okay. Thank you, Doctor.
I use that T, A, etc. because I follow exactly from the sequence diagram. You can have like only 5 minutes, 5M, and then 30 seconds. You can also have that. The one in the PowerPoint slide. There are many, it's a method of notation, time notation. Any other question? Okay, so if you have no question, yeah, you are right home. There is another explanation for that. If you use T1, T2, then we don't know the time unit. So we do not know the time if you want to use time unit. Okay, this one T1, T2, the one that I'm doing it now is it doesn't matter. But then if you want to really change that into second, for example, second here. Right, so you can change this T1 into start from 0, and then you calculate 5 minutes times 60, 300 seconds right now. So you can start from 0, and then how long it takes for this, along the same, and then this one, 300 seconds. Right, you can also have that. And then it means that the expand, the duration, the length of your time is more accurate. It's not estimation anymore. This one is more to estimation. T1, T2, T3, there is it's just like this. Okay, what happened at T3? Yeah, so it's a mining process for the Ethereum virtual machine, and then for the voter, this is a voting time. They are in the voting state. What happened at T6? T6, it means that Ethereum virtual machine is close and end state. Okay, but then for the voter, they will have a display message to have a display message to tell them whether it's a successful vote or not. So this is what they say for T1, T2, T3. What happened at this? What happened at T5, T6, something like that. You're not specifically say that what happened at this second, no. It's more on documentation. It's a documentation. It's a layman language. The one that you say is more very scientifically, computational, very specific. Should we add the state into our sequence? Yes. Yes. This is what I'm trying to say after this. Okay. All right. So here is a difference between sequence, state, and timing diagram. Okay, you can read this. So I give you another example. This is what I said just now. See, activate the wet sensor, at the same time barrier is lowered at the same time. See, and then this one changes. Okay, this thing is actually at the same time when it's lower and then it is blocked. Okay, so this is another example lah. Okay, for your project, okay, I just put it. First, check your state. Okay, and then can include time or another one, check your use case description. Okay, so can you include time? Then if yes, yes, change use case description for change sequence diagram. Okay. First, you have to check state and then check if you already have state lah. Okay. And then can you include time? If you cannot find from your state, then you have to go back to your use case description, reread again. Okay, so that you know where actually that you can include time. Once it's okay done, then you have to change that use case description, and then you also have to change sequence diagram. Basically, in other words, that is why I give you this example. You must change your use case description. You must change this, change use case diagram should be no problem. Another one, this. You must change sequence diagram. Include state and time. This one, okay, time, this, wherever possible lah. Okay, so whoever have done state diagram, so now I think the next thing to do is you have to sit together again with the timing person. State, timing, and sequence. You have to sit together and then to figure out where is it possible to change. Once you change your diagram, you have to talk with other members because you have to change the use case description as well. Okay. Any other question? So by right, last report, your sequence diagram will look like this. It's very beautiful. It's all the state and the time. Cantik lah. So that is very simple. Like after this, done. Okay, done, and you know. Any other question? Okay. So if you have no question, that's all for today. See you on Thursday for tutorial session of timing diagram. So just to remind you, next week you're going to have last part of final exam, which will cover activity diagram and state diagram. Again, there are two questions, case study, one to draw activity, another one to draw state. Okay. Duration, same thing. 45 minutes like previous, right? 45 minutes. And then what else? Huh? It's a drawing thing. Drawing diagram. Okay. So that's all. Thank you. See you. Bye. You're welcome.